Hey, welcome back to Frank's World TV on Channel 9. It's my distinct pleasure to welcome back Charis Loveland, who is a PM on the Cortana Intelligence Competitions team, and she's here to fill us in on how the Decoding Brain Signals competition went. Welcome back to the show and welcome to DC.
Thanks so much for having me in your glorious city here, Frank.
Thank you. Thank you very much.
The invitation and the opportunity.
So happy to have you here, especially in August. We're not known for having the best weather here in DC in August.
Yeah, sticking it out, decided to be a trooper and brave the humidity just because I'm so excited to report back our awesome outcome for the Decoding Brain Signals.
Awesome. So when we last spoke, you were at 90%. Now, a little birdie told me that things have gotten better.
Yeah, absolutely. So that was about a month prior to the competition close at the end of June. And so since then, we have several really impressive algorithms, and in fact our top score exceeded Dr. Kai Miller, the Stanford neurosurgeon's research on whose research this project is based. It exceeded the original algorithm by 13.75%. So we created a algorithm that has 93.75 accuracy. Our top winner submitted earned that score on the private data set.
So to put it in perspective, if you've not seen the original video, the original competition was based on data from a Stanford neurologist.
Yes.
Who wired people's brains to determine whether or not they're looking at a person's face or a house.
Right.
And the best he and his team could do, a Stanford neurologist, was 80%.
Yes, we got about 80% accuracy on the original data set. And then we crowdsourced that through our gamification platform, Cortana Intelligence Competitions. And over 3 months, we received many outstanding submissions, but the top score was nearly 14% better than the original research.
That's amazing. So you went from kind of this 80-20 type, 80% accurate, 20% not accurate, to now you're pushing the mid-90s.
Yeah.
And that's really transformative for not just machine learning. Obviously, that's good for for the team, but it's also good for good patient outcomes for the research.
Absolutely, it's really going to help Dr. Miller and other neurosurgeons better understand how our brains communicate and receive visual stimuli. So it's really exciting work.
So that's great. We have really great outcomes there. 14% better, above and beyond what a Stanford neuroscience does. So what's next? Like what's next? If folks missed out on that competition, do you have any new competitions going on?
We do. We just launched Women's Health Risk Assessment at the Hadoop Summit at the end of June. So we're really excited about this competition. The data set comes from the Bill and Melinda Gates Foundation.
I've heard of them.
Yeah, they're rather famous, in fact. And so women have come into clinics run by Bill and Melinda Gates Foundation and were given surveys. So this data set is comprised of about 9,000 women, 1,000 in each of 9 different developing regions in the developing world. So for instance, Myanmar, Kenya, Ethiopia, some areas of Asia. And we're asked a huge variety, pretty exhaustive list of survey questions. So essentially, they were asked about their health and background and demographics, their income, their religion, if they own a computer or a cell phone, whether they've had children, whether they're married, whether they use contraception, whether they cook over an open flame or a stove, the type of house or hut that they live in. And based on that data, we've put together a starter experiment, just as in Decoding Brain Signals, to help further and more accurately classify these women into risk segments so that we can better screen for health conditions as women come into clinics in the developing world.
Interesting. So, and you broke it out by those 9 different regions because you might find that something's a problem here, but not a problem there.
Right.
And then the purpose of that, I guess, would be optimizing the healthcare dollars.
Yes, absolutely. So it's segmented into these 9 regions, so that way we can find out what's similar and what's distinct in areas of Asia, different from West Africa, and so forth. But we're trying to find commonalities based on a woman's demographic. What might we screen her for going into a clinic so that we can very much accurately target the diseases at which she's at risk, but also to stretch those healthcare dollars further so that more women can be treated.
Interesting. And what makes this different, I suppose, is the two things. One, with the Brain Challenge, you were basically pulling in data raw from the machine.
Right.
Right. Whereas this, you're pulling information in from a questionnaire.
Yeah.
It's filled out by humans.
Exactly.
And with the previous the Decoding Brain Signals competition, house or face.
Right.
This seems like it's going to have more than one facet.
Exactly. That's an astute observation. So that Decoding Brain Signals competition was a binary classification, right? You have house or face. This is a multi-class classification problem. So even though it's a bit more complex and it's segmented out into these 9 regions, we've made it very simple for our users to get started. We've also made this type of research and this data set available to everyone, regardless of their background in data science or statistics or not, because it is a compelling world problem, and we want people to feel as excited and motivated by this really life-changing data set as we are at Microsoft.
What do you hope to find out? Like, do you have any, when you go into these science experiments, particularly if you have more than one facet, I mean, is there something that you're planning that you expect to see? Do you expect to see one type of disease being more common in West Africa versus Central Asia? Do you go in kind of expecting a certain amount of data set, or?
Yeah, I think we really let the data speak for itself, so that way we can look at, for instance, one thing I would expect very much to see is AIDS and HIV is the leading cause of death among women ages 15 through 44, and our segment of the data set goes women ages 15 through 30. So I would imagine that some sort of HIV screening would be recommended for most, if not all, of these women, as well as information and education about contraception purposes. So that's one thing I expect to see, but that's just based on the overall data set and some of the research that we've done to put this together. For instance, there's a great report that's linked on our competition's homepage that from the WHO, the World Health Organization, from 2011, that talks about a lot of these risk factors. But letting the data speak for itself, and once we get some of these more accurate algorithms, we'll be able to really dig in and screen, allow women to be screened for the tests that she's most at risk for screen for those diseases, but avoid any unnecessary and unneeded tests, so that way that money can be used to help other women.
So it's primarily an optimization strategy?
Yeah, exactly.
Okay.
And the nice thing about the way our competitions work is it's very easy to operationalize our web services. That's what you submit as a competition entry, is you're submitting a web service. So therefore you can take the winning algorithms and very quickly and accurately deploy them where needed.
Then if you've not played with Azure ML yet, I mean, that's one of the things that for me was really transformative, is that you create kind of this algorithms in your process, and you can publish immediately to a web service. So anyone that obviously you give access to can then make use of what you've learned, which I think is very transformative. So when you get the winner of this competition, you can give the access immediately to organizations like the Bill and Melinda Gates Foundation or the World Health Organization.
Absolutely. Our goals are really to find a way to make this research and these new findings available for use in the developing world.
That's amazing. And who would think that machine learning would enable better outcomes for women in these developing regions?
Yeah, it's really exciting.
Great. So where can people find out more?
So they should check out our website. They can go to aka.ms/women's health. And that will take you to a page that will give you a summary of our problem set, as well as detailed tutorials. We have a video where we walk you through step-by-step how to contribute that was put together by Hang, who was interviewed by you the last round for our Decoding Brain Signals.
Great.
So he teaches you how to do it, the ins and outs. We also have a Word document tutorial that will allow you to follow those steps and submit your very own web service to be scored on our competition scoring service and hopefully get you up on the leaderboard. We've had over 500 submissions so far since the competition launched on June 28th, and the competition will be open through September 30th. So we definitely encourage you to get in and try to get a more accurate algorithm than our top scorer, which currently is at just a little bit over 87%. So right now we're averaging about 7% over our starter experiment, but the hope is that we can reach an even higher score.
That's pretty impressive, actually. Is there going to be an internal competition? Because you smoked the last one, didn't you?
Not exactly smoked, but I certainly placed, in the top
Very
5.
Nice.
But yes, we do have an internal Microsoft-only competition going on as well, because while we can award cash and prizes to competition participants around the world, us Microsoft employees, we need to settle for bragging rights. So that's
which are very useful within the company.
Useful, yeah. So if you want to try the internal version of the competition, that's at aka.ms/MS Women's Health.
Great, and that's only Microsoft employees.
That's yes.
And just a reminder, you don't already have to be a machine learning expert or a data scientist to participate, right? I mean, a lot of this is your mission is to democratize this, and with the tutorials and stuff, you can definitely do it. In fact, when you play so well, you had exactly 4 or 5 months of data science behind you?
Yeah, exactly. I hit over, I think about 87% on the data set for decoding brain signals with, yes, nearly 3 months of experience of machine learning under my belt. So absolutely, our starter experiments and demos and tutorials make it very accessible for even folks who have very little exposure to coding in their background to give it a try. I've been joining my friend from Bates over next door at the Marriott Marquis with some physicists, and I've been promoting the competition there because many of them work in Python and coding for medical physicists purposes and know how to Python, so I encourage them to try it out as well. We have it open to everyone.
Great, and that's what's really inspiring about this, is that you don't have to be an expert in this. And who knows, if you join the competition, one, you might win, and even if you don't win, you might find your next career option.
Absolutely, and we're giving away $5,000 in cash prizes. So the grand prize winner will receive $3,000,
nice.
$1,500 for our next finisher, and then $500 for the third place finisher.
Pretty good. All right, well, be sure to check out those links, and I post them in the description below. And thanks for watching Frank's World TV.
Thanks, Frank.
Hey, thanks for coming back.
Absolutely.